Meet the rocket that's rewriting history, 3D printing's space revolution. The year 2025 marked a pivotal moment in aerospace engineering, as Relativity Space, a trailblazing California-based company, achieved a significant milestone with the inaugural launch of its groundbreaking, nearly fully 3D printed rocket, the Terran 1. Blasting off from a historic launch pad at Cape Canaveral, Florida, this event was more than just another rocket launch. It represented a profound leap forward in the application of additive manufacturing on an unprecedented scale within the demanding confines of the space industry. While the Terran 1 ultimately did not achieve its full orbital objective, its second stage failing to ignite and the vehicle subsequently descending into the vast expanse of the Atlantic Ocean. The mission was unequivocally a resounding success in demonstrating the viability and immense potential of 3D printing for rocket construction. This partial failure, far from being a setback, yielded invaluable data and validated a revolutionary manufacturing approach that promises to fundamentally reshape how rockets are built and launched. What set Terran 1 apart was its astonishing reliance on 3D printing techniques. An astounding 85% of the rocket's entire structure, from the expansive fuel tanks that housed its propellants to the intricate, minute components within its engines, was meticulously crafted layer by layer using advanced additive manufacturing processes. This level of integration was previously unheard of in the aerospace sector, where traditional manufacturing methods involving extensive machining, welding, and assembly have long been the norm. Relativity Space's ambitious long-term vision is to push this boundary even further, aiming to achieve a figure of over 95% 3D printed components in their future vehicles. Under this radical paradigm, only a select few elements, primarily sensitive electronics and specialized valves, would continue to be produced through conventional means. This audacious goal underscores the company's profound belief in the transformative power of 3D printing, not just as a niche application, but as the core manufacturing methodology for the rockets of tomorrow. The benefits are manifold: significantly reduced part counts, streamlined supply chains, enhanced design flexibility, and potentially a drastic reduction in production time and cost. Standing an imposing 112 feet or 34 meters tall, the Terran 1 was not just a marvel of 3D printing, but also an advocate for cleaner propulsion. It utilized liquid methane as its propellant, a fuel celebrated for its cleaner burning characteristics compared to traditional kerosene-based fuels. This shift towards more environmentally conscious propellants is anticipated to become an increasingly common trend in future space launches, aligning with global efforts to mitigate the environmental footprint of space exploration. Despite not reaching orbit, the Terran 1 achieved several critical mission milestones that provided invaluable validation. Crucially, it successfully navigated through max Q, the phase of maximum aerodynamic pressure during ascent. This moment of immense stress on the rocket structure is a critical test of its integrity, and the Terran 1's successful passage through it unequivocally proved the structural soundness and reliability of its 3D printed components under extreme flight conditions. This achievement alone was a profound vindication of Relativity Space's manufacturing approach, offering tangible proof that structures built through additive manufacturing can withstand the rigorous demands of spaceflight. The data meticulously collected from the Terran 1's flight, encompassing everything from engine performance to structural dynamics, is now being meticulously analyzed. This invaluable information will directly inform and guide the iterative improvements necessary for future launches, enabling Relativity Space to refine their designs, optimize their manufacturing processes, and enhance the overall reliability of their rockets. The Terran 1, while an impressive achievement in its own right, serves primarily as a foundational prototype for Relativity Space's larger and far more ambitious vehicle, the Terran rocket. The Terran represents the company's full realization of its revolutionary vision, designed to be a heavy-lift launch vehicle capable of ferrying an impressive 20 tons to low Earth orbit. Furthermore, and perhaps even more significantly, the Terran is engineered to be fully reusable, echoing the pioneering reusability capabilities of SpaceX's Starship system. Reusability is a game changer in the space industry, promising to drastically reduce the cost of space access and enable a far higher cadence of launches. By making rockets more akin to aircraft capable of multiple flights with minimal refurbishment, reusability opens up entirely new possibilities for space commerce, exploration, and scientific endeavors. The first flight of the Terran is ambitiously targeted for 2025, a testament to Relativity Space's rapid development pace and the inherent efficiencies offered by their 3D printing approach. Even before its maiden launch, the Terran has already garnered substantial attention and significant commercial interest from a diverse range of clients. Relativity Space has successfully secured over $1.2 billion in future launch contracts, a remarkable testament to the market's confidence in their innovative technology and business model. A particularly noteworthy agreement is with OneWeb, a prominent UK-based satellite broadband company. This partnership highlights the growing demand for reliable and cost-effective launch services to deploy large constellations of satellites for global connectivity. As the burgeoning satellite industry continues its rapid expansion, the need for efficient and frequent access to orbit will only intensify. In an era characterized by surging demand for rocket launches and the emergence of dynamic new players in the commercial space market, Relativity Space's innovative approach is poised to reshape the future of space exploration. Their commitment to fully 3D printed rockets, coupled with the pursuit of reusability, positions them as a formidable force in the evolving aerospace landscape. The traditional barriers to entry in the space industry, prohibitive costs, lengthy manufacturing cycles, and complex supply chains, are being systematically dismantled by companies like Relativity Space. By demonstrating the efficacy and potential of additive manufacturing, they're paving the way for a future where rockets can be designed, iterated, and produced with unprecedented speed and efficiency. This paradigm shift holds the promise of democratizing access to space, fostering greater innovation, and accelerating humanity's journey among the stars. The flight of Terran 1 in 2025, though not fully orbital, was a crucial first step in what promises to be a revolutionary chapter for aerospace. As we look to the future, the lessons learned from the Terran 1's pioneering flight and the continued development of the Terran underscore a transformative shift in how humanity accesses space. Relativity Space's audacious vision, centered on the power of 3D printing and reusability, isn't just about building rockets. It's about building a new paradigm for space exploration itself. The ability to rapidly iterate designs, drastically reduce manufacturing lead times, and produce complex structures with unprecedented precision through additive manufacturing promises to unlock new possibilities. Imagine a future where launch costs plummet, enabling a surge in scientific research, commercial ventures, and even space tourism. The Terran with its robust payload capacity and reusability, is poised to be a key enabler of this future, facilitating the deployment of vast satellite constellations, supporting lunar and Martian endeavors, and opening up new frontiers for human ingenuity. The aerospace industry is on the cusp of a revolution, driven by innovative companies like Relativity Space that dare to challenge conventional wisdom. The echoes of Terran 1's launch from Cape Canaveral reverberate as a testament to what's possible when cutting-edge technology meets unyielding ambition. As the Terran R prepares for its maiden voyage, we stand at the precipice of an exciting new era, one where access to space is more frequent, more affordable, and more sustainable than ever before. The journey has truly just begun. If you're as excited as we are about 3D printed rockets and the incredible advancements in space exploration, then you won't want to miss our next video. We'll be diving deeper into the technology behind these game-changing innovations and what they mean for humanity's journey to the stars. Hit that subscribe button right now and turn on notifications so you're the first to know when our new video drops. Let's explore the cosmos together.